Structured query means that define the formula structured way. Like if you want data, select whatever data you need to select, then from which table you want, and the where clause if required. That's what is the condition. This is a structured way. But in a Mongo, there is a document or the file are saved. It's not a structured way to pull out data. That's why this is in NoSQL. It's not structured data. Apart from one more thing is RDB means structured SQL are queries are fired on relational database. Means they have the relation with each other, like tabular format. So one row have the another relation with these, or one from another table have the relation, these key have the relation with these. That's kind of things are there. So this is the basic about the SQL and NoSQL. But in if you discuss about the type, means what type of data is stored. So we know that in a structured way that you can consider this is an Excel kind of thing, or structured way tabular format data is stored in a NoSQL database. In a NoSQL database, data is stored on a key value pair, or the whole document gets stored, or the columns data are stored, file are there, JSON is there. Any kind of data you can push into NoSQL databases. Yeah, that's the basic about the type things. In language, we discussed, like structured way we can organize, we can access the SQL data. That's why the structured query language is came into picture. And in a NoSQL database, data is not defined. Like document will be there, JSON will be there, file will be there, key value will be there. So access each thing, there are different ways. No, not standard way are defined. So that's the language thing. Scalability point of view, suppose the MySQL thing, currently you have a 100K record and you are working with a 1 GB RAM and 1 core as a CPU, and after suppose 3 year, after 3 year this data goes beyond 10 million. So same like this is not working, you will get the performance bottleneck. But if you increase 1 GB to suppose 8 GB and you will add some CPU like 4 core you added, so that time you will get similar kind of performance. So this means like as a vertical scaling, you can scale your, as your hardware cost you are increasing, performance will get better and better and better. But they have also some limit, but you can consider this is a vertical scaling, means as you scaling hardware, your performance get increased. But in a NoSQL, it is a horizontal scaling, means you can shard the data. Means if you have suppose earlier I explained this 1K and means this example 100K is the data. So you can easily shard data into 10K, 10K and 10K. Like 10 bucket you can create 10K, 10K. So horizontally you can scale the data. Apart from that, means it's distributed system kind of database. So that there are easy to scale, easy to shard. All the things are horizontally, means 10K, 10 bucket you created. That means it's scaled by horizontally and distributed, or this is a one system, this is another system, this is another, till 10 you have 10 system. So that's why we are saying this in a NoSQL database horizontally easy to scale. This is okay. This also scale horizontally, but they have different types. Means it's like master slave architecture, you need to build, put lot of efforts, but it's easy to, if you add extra hardware, it's easy to scale. And in this scale, in this NoSQL database, if you add more like horizontally, it's getting easy to scale. Okay. But we discuss about the structured schema and query thing. The property, like the MySQL provides the ACID property like atomicity. If you insert the data, that means it's insert or it's filled. There is no meaning by dialing we half data updated, half data is not updated. That never happen in MySQL. The consistency, if you have a 10 servers, like 1 master and 3 servers, 3 slave, if you updated the data on a master, that there is a guarantee that data get reproduced over all the machines apart from the same table. If you hit that, if they return us that it's updated, that means updated. That's the ACID property. CAP theorem will consistency, availability and partitioning, that provide in a NoSQL, like we already check here, like a 10K is a partition. Availability data is available through this instance at a 10K. So CAP will evaluate in a more details in a section. We'll create a different session for that, for ACID purpose, and for CAP theorem we'll discuss in details, because it's required 10 to 20 minutes. In details we require just to provide. ACID is provided by MySQL databases, and CAP theorem is based upon the NoSQL. NoSQL can provide CAP functionality. Okay, so basically if you go with the NoSQL also have the option, means is your database stored key value, is your database stored column, is it in a document or a JSON format, or this is a graph kind of a database. So based upon your requirement, you can choose any one of them. Suppose if you want a high performance, then you can go with first 3. But graph have not that up to mark performance. If you want to scalable, then you have only 2 options, like key value and column. And the flexibility, if you want, then only you have only key value. But key value complexity is not the it won't get complex things you can achieve using key value store database. So yeah, that's the basic thing about the NoSQL database. Means it's trade-offs, what you want and what thing you sacrifice to achieve that. Means if you choose the key value thing, you will get performance, scalability and flexibility, but you won't get a complex thing. You just need to put data into simpler format. Yeah. That's about the SQL and NoSQL. So you get basic idea when to choose SQL, when to use NoSQL. In a NoSQL, what kind of store you can choose, key value, either document, JSON thing. This is like just an example, like enterprise applications, mobile applications. Apart from that, they are using the SQL databases because they require the relation. Employee have the address, employee have the salary table, employee have the department. All the details are there. So there are mapping between one to one, one to many. So we are going with the relational database. Apart from that, relational table have the provided implicitly functions like sum, average, group by, all the things are there. So most of the enterprise application or the service application chooses go with the SQL. But if you are a game, Facebook, Twitter, social things like Facebook, one friend have 1,000 friends, so you cannot put into database. Their graph kind of database is required. IoT thing, Twitter or any large applications, or whenever the graph tree, that kind of data is equal, simply people go with the NoSQL kind of thing. So yeah, that's the basic thing when you choose SQL and NoSQL. Apart from that, I noted few points where we can compare like SQL versus NoSQL, or whether we should go with the SQL or NoSQL. We'll see in a below table. Okay, so the definition we already know that it's a SQL database called a relational database. This is a non-relational distributed database. Design we know that it's the syntax and get the data. It's a traditional RDBMS data. Using the queries we can get the data. This is a modern application and on demand present, the data get represented. Structured query is required, no declarative, means on the spot we can create the queries, no structured as such required. SQL database are a table-based table, means we require table, view, indexes, trigger, all the things. NoSQL we already did, so is document, key value, graph, JSON, anything you can store into NoSQL databases. Vertically scale we check, and this is a horizontally getting scaled. Oracle MySQL is the example here. MongoDB, Redis is the key value, which is very known database in IT industry. So most of Redis, Cassandra, HBase, all these things are using, means one application, one organization, one application uses Redis, one using Cassandra or HBase, because each one have different advantages and different disadvantages. We'll cover in details about in a NoSQL session. Hierarchical data storage means it's kind of hierarchical data, means normalized data can store here, not normalized data stored. It's only supported in a key value because graph and other are as the one document are there. We cannot link one document to another, or one column inside the JSON field it won't map with another thing. This is the year related thing. Currently means in 20s they started. It started from 90s. Apart from major point is on open sources. We know that both are the open sources, but the MySQL and Postgres provide some licensing fees also if you want to require the support from that, but it's in open source, and commercially also they were providing license. Consistency, strong consistency it provides, and here means MongoDB were offer only means eventually consistency, like Cassandra also is a best example. Acid property we already discussed about the acid property, and here solving the data availability problem. NoSQL is like we discussed the CAP theorem in a CAPS A for availability. So data availability, apart from this we discussed that 100k record divided into 10k bucket. So this is also availability example. It should be data validation is super important because the everything is a structured way. So validation is required. If column is an integer, you cannot put string inside there, but it can possible here. That's why it's have faster and faster. Best option means dynamic queries. When you need support of dynamic queries, you can go with the SQL, and the scale and requirement is a consistently changing. So adding one element in a JSON, it's not that much, but adding column in a table, it's required time, it's required the code modification, everything is required. So specialized DB and hardware is required. Apart from that, support also required from if you are using MySQL as a production, you require some expertise from MySQL, and also this is not that expertise required. Community hardware also fine, network also fine, driver storage also, HHS also fine, but here we required the SAN, RAD or SSD to provide the better result. Highly available network also required. Base feature, cost platform support and secure and free, and here easy to use, high performance and flexible tool provided. I think most of the points we covered. We covered that atomicity, consistency, isolation, durability stands for it's part of RDBMS, but here basically we are available at all the time. It eventually consistent, not consistent, and subset. So CAP theorem is applicable for NoSQL database. This is the basic about the SQL, NoSQL, where to choose, what to choose, NoSQL options also. That's it. Thank you so much.